This connector. Okay. All right. Okay. So there's this term called redox. I've got no paper to write. Okay, so redox. My son forgot to pack my pen for me. So redox is when oxidation and reduction happen at the same time. Okay, that's how you see what redox is. So, what is oxidation? Oxidation is when a substance gains oxygen. Okay, so for example, you see here, so this is all oxidation. Okay, here, first you have Mg. It gains oxygen to become MgO. Okay, so because it gains oxygen, it's called oxidation. So we say magnesium is oxidized. We don't say magnesium oxide is oxidized. No, magnesium is oxidized to magnesium oxide. Okay, and then um, sulfur, first no oxygen becomes sulfur dioxide. Then sulfur dioxide, add some more oxygen becomes sulfur dioxide. So both of it is also oxidation. Okay, reduction is the other way around. Remove oxygen. So you see, at first got CuO, then in the end no more. It's supposed to be Cu plus MgO. Let's add plus a C. Okay, so at first got CuO, got oxygen, then when it becomes here, no oxygen. So what happens is the oxygen is removed. So we say CuO is reduced. Okay, can? Okay. And then Fe2O3, same thing. Here got oxygen, then suddenly no oxygen. So we say it is reduced. Okay. Now, loss or removal of electron. Yeah. If you lose electron, it is oxidation. If you gain electron, it is reduction. So if the electron is at the back, it is electron loss. You see that? Yeah. Become, okay. If you gain electron in front, it's reduction. Okay? And then finally, increase or decrease of oxidation number. Can? Okay. If the oxidation number, we're going to learn that later. If the oxidation number goes up, it's oxidation. Oxidation number goes down, it's reduction. Okay. So is this redox? So redox is when both happens at the same time. So Ya is redox. Why? Zinc is oxidized to zinc oxide. So usually this is how we write. We write oxidation, redox. We write oxidation on top of the one that's oxidized. And then lead oxide is reduced to lead. So yes, this is redox. And then this one is also redox. Huh? CuO becomes Cu. This is reduction here. So CuO reduced. And then H2 is oxidized. Right? Can I understand? Okay. Now, if somebody were to be oxidized, right? If somebody like zinc at first no oxygen and then become oxygen, it must get the oxygen from someone, right? So zinc got the oxygen from lead oxide. So who is the one that caused zinc to be oxidized? Lead oxide. So we say that lead oxide, PbO, is the oxidizing agent. Okay? PbO is the oxidizing agent. Now, oxidizing agent means I cause somebody else to be oxidized. Okay, it causes zinc to be oxidized. But it itself is what? But PbO itself is what? Reduce. So that's how you define oxidizing agent. Can I understand? Okay. So when they ask you what is the oxidizing agent, you say oxidizing agent is the one that is reduced and causes another substance to be oxidized. Okay. So if there's an oxidizing agent is reduced, reducing agent is oxidized. So CuO is reduced, right? CuO is reduced because H2 stole the oxygen. Okay. So H2 is oxidized, correct? H2 is oxidized. So H2, yes, is the reducing agent. Why? It causes CuO to become reduced. It causes the other way around. It's like my car agent sell me a car. My car agent cannot buy a car. Stupid, right? Then you what kind of car agent are you? Instead of selling cars, you're buying cars. It doesn't make sense. Okay, get it? Okay. Now comes this called oxidation number. Okay, the only way I can do this is I have to show you all the screen, and I'm going to can you put the board for me, Joe? I'm going to do it on the board. Ryan's hard work. Yeah, Ryan's hard work. Because my okay, because my pen has disappeared. Okay, I only need this part. I only need this part to see. There. This is like the old time when COVID first started. Not everybody got writing pad. Teachers all write on the whiteboard like that. Remember not? This is like old times like that. Huh? You can video me, but then you won't be on the Zoom. This is the Zoom meeting recorded. Ah, eh? Yeah, so this is directly is a Zoom meeting recorded. It's still being recorded now. Okay, wait, wait a bit. Then I can have the whole screen. So funny. Okay. Oh, I need a little bit more, little bit more. Thank you. Wait, how old were you guys during COVID? I guess like 8 years old. No, no, no. About 10 years old, right? 10, 11 years old, right? Yeah? Nine. So this is like last time lah, when COVID first started, all the teachers were trying to do online classes, right? And then didn't have writing pad or anything. So good. Okay, now, so we're gonna learn something called oxidation number. Is it? Is it? Is it? Oh no. How? There's something I can do, right? There is something I can do to flip it, right? What is it called? Okay, wait, let me pause the record. So, oxidation number. Okay, so oxidation number. The first rule that I give you in your notes is it's zero, right? When it's an element. What does it mean by element? If they just write magnesium alone like that, the oxidation number of magnesium is zero. Okay, because, okay, now you must understand, element is not ion. For ion, magnesium ion, the oxidation number is positive 2. So if it's in MgO, you cannot happily tell me, oh teacher, magnesium atom, oxygen atom. No. In MgO, that's why you learn already ionic compound. Mg2 plus O2 negative. So the oxidation number of magnesium in magnesium oxide is N plus 2. In oxygen it's negative because this is element, this is not element, so there's a difference. So if I say Cl2 is also 0 because it's two of the same atom. So as long as it's alone, no charge, the oxidation number is always zero. Okay. But if it's an ion or compound, okay, ion or compound, then it's different. So, for example, this one, oxidation number of magnesium is +2. Oxidation number of oxygen is -2. When you add it together, it becomes 0. So in a compound, the total is always 0. Okay, in a compound, the total is always 0. Okay, so like this. If I have CaCl2, okay, calcium is +2. Why? Because calcium ion is 2 positive. Cl, we know that in here the Cl is -1. So it's -1, but there is 2 of it. So the total still equals to 0. Can I understand? Okay, now, what other rules that we have? The compound is 0. The element is 0. The compound add together is 0, element is 0. Inside got numbers. Okay, next one is, yeah. Okay, so it's very easy to have groups of them. So if they are in group 1, everybody in group 1 always +1. The oxidation number is always +1. Everybody in group 2 always +2. Okay, group 3 always +3. It follows the ion. Now, what about oxygen? Okay, depends. So if you look at rule number 4, okay. So if it's alone like that, remember, this is 0. But if it's in water, hydrogen is +1 times 2. Okay. Oxygen, -2. Add together, it equals to 0. Okay. So the total will equal to 0. The total will still equal to 0. All right. Now, but what if I have H2O2? H2O2, hydrogen peroxide. Okay, now what happens? Hydrogen is still +1 times 2. Oxygen cannot be -2 now, because if oxygen is -2, the total is not 0. So we need to count. So in a hydrogen peroxide, oxygen is -2, -1, sorry, times 2. You add these two together, you still get 0. So in water, in everything else, oxygen is -2. So this one, +2. So that's why this is copper 2 oxide. Now, why suddenly got 2 oxide, but CuO, MgO, we don't call it magnesium 2 oxide. We just call it magnesium oxide. Why? Because group 1 metal, 2 metal, 3 metal, their oxidation state is just +1, +2, +3. But for transition metal, okay, for transition metal such as copper oxide, copper, iron. So iron, there's a few. There's iron 2 and iron 3. So here, can you count the oxidation number? It's not. It's +3. So this is iron 3. This one is +2, so iron 2. So this one is copper 2, right? What if I wrote Cu2O? Total equals to 0. 2 copper. Oxygen -2. So copper is +1. So this is called copper 2 oxide. This is called copper 1 oxide. So you see, there's various oxidation states. Okay, can. So that is the laws that we have to follow. So what I want you to do is look at your notes, page, this one. Okay, exercise here. Okay, calculate the oxidation number of everybody who's underlined. Okay? I remember doing this. Yes, I remember teaching you this. It's okay, now you can remember. What's the first one?
First one, F and O.
Yeah, no. Okay. Oh, I cannot see.
Wow.
Okay. Ting, ting, ting. K, M, N, O, 4. Can it? Okay. So we're supposed to look for Mn, right? Okay, so potassium group 1, positive 1. And manganese is X. Oxygen is negative 2 times 4. X equals to positive 7. So this is called potassium manganate 7. So if they ask you what is the 7 for, the 7 is the oxidation number of manganese. Does it? So that's the whole point. No, I'm teaching you the name now.
Potassium manganate 7 for group 7, right?
No, it's oxidation. This is transition metal. If it's not transition metal, no need to write. Okay, Cr2, the K2 Cr2O7. So 2x plus 2 times 1 plus 2x equals 2 chromium plus the negative 2 times x equals 0. X equals to positive 6. So this is called potassium dichromate 6, correct? Right. General. So these two are things that we use for oxidizing agents. C is Fe2O3, correct?
Yes.
Fe2O3. So 2x plus negative 2 times 3 is 0. So x equals to positive. So iron 3 oxide. Okay. FeSO4. Positive 2 because this one is negative 2. Iron 2 sulfate. Okay. Okay, E we did just now. PbO. Pb is positive 2, so lead 2 oxide. Because Pb is positive 2. Right? Did you get it correct?
Yeah. Should be.
Because positive 2, negative 2 cancel each other out. So when you come to this, a little bit different. PbO2, then how?
What is D? D is
Iron 2 sulfate.
so 2 is the answer.
Positive 2, yeah, it's right in that. You should remember.
I multiply 2 because of the SO4.
I don't think so. SO4 is 2 negative. The whole SO4 is 2 negative. You know the charge?
Yeah.
The ion SO4 is 2 negative.
Oh, really?
So this is a bit different. This one is X plus oxygen is negative 2 times 2. Right? So this one total equals 0. X equals to positive 4. So this is lead or oxide. Okay? Okay.
Yes.
So it's a H2SO4 and H2SO3. Okay? So positive 1 times 2 plus x plus negative 2 times 4. So x equals to positive 6. And then this one is same thing. X equals to positive 4, right? So this one there's no special name. They call it sulfuric and sulfurous acid. But what I want to emphasize is there is also oxidation state difference in sulfur, in non-metals, not just transition metals. Okay, is it the last?
Yes.
Okay, now, what do we do with these numbers? So, let's look at this. So I have a very simple equation. Sodium plus chlorine becomes sodium chloride. Let's say, okay, sodium is the element, right?
Yes.
What is the oxidation number of sodium? Zero.
Zero.
Why is it zero? Because
it's full
element.
element.
So chlorine is also zero. So sodium is positive one, chlorine is negative one, right? So sodium goes from zero to positive one. So the oxidation number went up or went down?
Went up.
So oxidation number went up. This is oxidation. Okay. This one went from zero to negative 2. So the oxidation number went down. So this is reduction. So in this one equation, there is oxidation and reduction. So this is known as redox. Okay. So although we cannot see the oxygen, we cannot see the electron, we can see the oxidation number. Okay. Okay, do the questions. Okay, so we try this one. Okay, so if you look here, potassium is group 1, so it's positive 1. Iodine is negative 1. Okay? Right? Mm, there. Smaller. Ta-da! Okay. Lead is positive 2 because the entire nitrate is a negative 1 charge. This potassium is still an ion, so it's still positive 1. The whole nitrate is negative 1 because it's a NO3 negative 1 ion. Lead is still an ion, still is still positive 2, is lead 2 iodide, and iodide is negative 1. So nobody changed. In this whole thing, nobody changed, so it's not redox. Get it? Nobody changed at all. Understand? Okay. Then you try this one. So remember, if there's no, very easy to see lah. If there's no element, everybody ion, that means usually not redox. Okay, potassium is group 1, positive 1. Oxygen, negative 2. Hydrogen, positive 1. You add these three together, is it 0? Yes, hydrogen, positive 1, chlorine, negative 1. Add this together, 0. Potassium, positive 1, chlorine, negative 1. Hydrogen, positive 1 times 2, oxygen, negative 2. Did anybody change? No. So also not redox. You understand now?
Yes.
You want to try C by yourself or not?
No.
Okay, write this out first. You try to understand first. Look at it properly.
I think what I did is correct, but the problem is, I want to see the actual redox equation, not like everything turns to zero zero.
All right. Okay, this one. Hydrogen is positive 1. Fluorine is negative 1. Negative 1. Magnesium is an element, so it's 0. Then here become negative positive 2 because it's the ion. Chlorine is negative 1. Hydrogen is 0. So now got ready lah. See? Chlorine doesn't change, but hydrogen, negative 1, positive 1 to 0, go up or down? Uh, this one from 0 to positive 2, go up. Okay, so
Do I need to consider the number in front?
No, of course not. No need, no need, no need. So hydrogen,
Wow.
hydrogen is reduced. Hydrogen is reduced from positive 1 to 0. Magnesium is oxidized. Can see or not? From 0 to positive 2. Jung, okay?
No.
Okay, 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 think for a while. Okay, you look at the question first. I don't talk to you first. You think first. You think first. Don't stress. Don't stress. You think for a while first.
Very sleepy.
Very sleepy. Oh, sleepiness. I cannot do anything. I cannot unsleepy you.
That can be.
Hmm? No, no, no. I have candy, but it's Himalayan salt candy. Lemon Himalayan salt. I don't know whether you will like.
I know that can be.
You like then you take it.
Yeah.
No.
I'm not sleepy.
It's salty and sweet. You try one lah, then you will know. It's very hard to explain.
Mm. Thank you, teacher.
You're welcome. Is it nice? Do you like the taste? Okay. Right.
It is so.
Oh, yeah, a little bit. Okay, can you understand this? So is this redox? Yeah, so this is redox. Get it? Okay. This one, zinc is element 0. Copper is, that's why you got all the copper is positive 2. Sulfate, the entire ion is negative 2. Then here, zinc is positive 2, because it's the ion, and then sulfate again negative 2, SO4 2 negative. And then here copper is the element, so 0. You've got to look at the zeros, I think. So zinc is 0 to positive 2 oxidation. Copper is from positive 2 to 0. Can see or not? So zinc,
Only looking at the element, not
ah,
the
so zinc is oxidation and copper 2 ion is reduction. This one.
Now I know it. Now I knew it.
Mm.
Only the one
Yeah,
aspect, not the
yeah,
whole
don't
thing.
simply take both, yeah. This one, positive 2 to 0. Can see?
Yes. So let me redo the last one.
Okay, okay, you do the last one, do the last one. So you want to do? You want to do some more questions? Or want to discuss? But I think the rate of ratio for them to come back and discuss. Okay.
The rate of reaction paper, it was kind of repetitive
Yeah.
because like, it was like most of them were like one marker.
Oh, I know it. Okay, we come back and then we do.
Yeah.
We Ready?
Yes.
Okay. So, okay, wait. Alright. So potassium, +1. Iodine, -1.
Yeah.
Bromine is 0.
Zero.
This one is positive. Element what? Bromine -1, and then this one is 0. Right or not? Element, right? I think Jomo needs to do some more.
No.
You don't seem to get it.
I wanna do new things.
You want to do new thing, but then the old thing you don't know how to do. This one is reduction.
Reduction.
Oh, reduction. And this one is oxidation. Get it or not?
Okay. Get it.
Yeah. Okay, you go to the toilet, go wash your face, go drink some water. We do something different. Okay, take a 5-minute break.
It's okay. The kid.
All right. So, oh, mm, okay. See ya. NO to NO3. So it's oxidized. Betul. This is oxidized.
I know two, right?
NO to NO2 is oxidized. This one is oxidized. Wait, not to finish it. And they're asking what's correct. So NO is oxidized. This is the first question. Oh, sorry. No wonder you're so confused. Okay. Describes oxidation. Okay, oxygen is added, electrons are lost. Oxidation state is increased. Yeah, B. Correct? Okay. Magnesium reacts with iron trioxide. Which statement about is correct? Magnesium, iron. So remember, oxidation and reduction only can talk about the reactant only. Magnesium is oxidized. C.
Yay.
Okay. When copper is heated in air, its surface turns black. What happens? So copper is oxidized. What else can happen? Copper becomes copper 2 oxide, which is black. Lead 2 oxide undergoes number of different redox reaction. Which reaction lead 2 oxide is not reduced? As long as it, okay, you see, compound element, compound element means something happened. So you just see that this one is still compound. If you notice, everybody else is compound element, compound element, compound element. So you just choose the one that is different. Actually, MCQ not very hard. You just choose the one that looks different. The final question is a redox reaction. Underlying substance being oxidized. No. There. See ya. You know why? Because CO becomes CO2. Right?
Yay.
Okay, this is the one. Okay.
That's a close.
Okay, NO is oxidized, correct. O3. O3 is reduced. Because it becomes O2 ma. Get it? MgO is oxidized. So the answer is A. Oxidation state of Fe. Fe is 3 plus.
3 plus, right?
This is iron 3. What we did this question just now. This is same as just now. Which is answer? Oxygen is added, electron lost. B, correct.
Is that reduction?
Oh, is it reduction? Oh my goodness.
Oh, it's
It's the other way
reduction?
around. It's
No.
not the same question.
I thought it was
Loss, added, and decreased. So C.
No.
Oh yeah, my goodness. I never opened ISBB. Reduction. So funny.
I got one wrong. No. In exam, like this kind of mistake come out, right? I will definitely cry.
Lah. If this kind of mistake come out, you also don't know what.
Oh, actually, yeah. When I solve the question, I don't know how.
Yeah, never mind. Just focus on the exam. Don't focus on results or whatever. Okay. This one is copper 2 sulfate because it's a transition metal. Potassium manganate 7. How you know just how we counted already? This is iron 3 chloride because the iron here is positive 3. Potassium iodide is used. Oh, okay. Potassium iodide is colorless.
Oh, really?
Potassium iodide, it will become iodine. Potassium iodide will become iodine. Potassium iodide is a reducing agent. That means it always reduces somebody else. Okay, can? So the color change of potassium iodide, we actually did this last week. From what color to what color? Colorless to potassium iodide is colorless. We did it in the halogens.
Gray.
No, iodine solution is brown. Iodine solid. So the color changes from colorless to brown. Okay, so because this is a reducing agent, it reacts with oxidizing agent. Get it not? Reducing agent will react with oxidizing agent. So which color describes what happens when potassium iodide is added to acidified containing an oxidizing agent? So color change turns brown. Turns brown. Iodine is formed. B. Get it? Okay, a series of redox reactions are shown. The oxide. Okay, highlight this word oxide. Why cannot be C? C is not oxide. So the answer must be A, C, or D. So it's oxidation. CO becomes CO2. The answer is A lah. NO becomes N. So reduce. Fe2O3 becomes Fe, reduced. Get it? Which reactant is being reduced? Like B lah. Add electron, right? Get it? Vanadium is transition element. Undergo oxidation. Okay, so this one you need to count all the oxidation numbers.
Actually,
I don't know how you know. Okay,
simply
so this one, this is positive,
positive 2, 3.
positive 3, and it becomes
1.
positive 2. Okay, this one is, the second one is positive 5 becomes positive 4. This one is positive 3 becomes positive 5. This one is positive 4, positive 4 becomes positive 3. So easy to see now.
Oh,
Which one undergoes oxidation? Only one, the oxidation number go up. Who is that? C.
oh,
Can see it not?
actually like that.
Yeah, that's why I said just use the same concept, count. Then you lazy to count what I want to
Still correct.
do. Lucky.
No, I see the V2 and V2 is the same. Then O3 become to O5. So I saw oxygen number in B. C should be the answer.
Okay. Manganese is a transition element from same question lah. Okay, same thing lah. So this one, Mn is positive 3. This one is positive 7. This one, positive 2 becomes positive
3.
6. This one is positive. No,
Oh, 2.
yeah, 2. Becomes
4.
positive 2. No change. Can see why not?
Because the
Same.
same.
This one is positive 2 becomes 0. So only one thing becomes smaller. D. See?
How I get correct if I don't do that?
How I know how you get correct? Maybe you do loss of oxygen.
Yeah.
Correct.
But actually, what are you doing? Like finding Mn and then
The finding the oxidation state, yeah.
what's Mn?
Manganese is a transition metal. It's written on top there. OMG is written on top there.
No, like the iron.
It's,
Well, how can I know?
yo, this is algebra. All oxygen is -2.
I know that.
So then, -2 times 3 equals to 0. So what is Mn? 2x equals to? Like that. Are they?
What's Mn?
Manganese. It's a transition element.
Also, consider that it is X and then
Yes, of course. How do you think we were doing this now?
I think it was written in periodic table.
Yeah, when I talk, you're like, not, but no one is listening one. Okay, potassium manganate is KMnO for acidified. Okay, it must be acidified, then it can work. It is an oxidizing agent. And the color change, the original color is purple. It will become colorless when it reacts. Okay, potassium manganate 7 is used to test the presence of reducing agents. Opposite because it's an oxidizing agent. So what correctly describes what happens to potassium manganate when it's reacting with a reducing agent? Color change is purple to colorless, purple to colorless. Okay, and then reason for change, it is reduced because the oxidizing agent is reduced. Get it? Which rule correctly describes oxidizing agent and a reducing agent? Adds oxygen to a substance, removes oxygen. A lah.
Oh,
Removes oxygen and adds oxygen. Right. It oxidizes somebody else. Right?
oh yeah.
Which of the following are commonly used as a reducing agent? So, this one you have to, this one I teach you is hydrogen peroxide. It's not in your syllabus anymore.
I got correct.
Very good.
Wait, for 6, isn't it C?
I think oxygen to
Sorry, wait. Sorry. D.
oh,
CO.
Like the number 6.
Number 6.
Oxidizing
Removes oxygen
agent.
from a substance. No. Oxidizing agent is not oxidation. Oxidizing agent undergoes reduction. So it adds oxygen to a substance. Okay, this one is CO, CO. Reducing agent. Reducing agent because it loves to grab people's oxygen. Okay. In which of the following reaction in both is acting as a reducing agent? So reducing agent is oxidized. So this one no, net. Oxidized, net. Ding, 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 ding. Number 2. Oxidize, yes. Ding, 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 ding. This one, reduce. So no. So 2 and 3. Okay, why not answer one? 2 and 3. Hydrogen and copper oxide react to produce metal water. Okay. So CuO is reduced. It is reduced. So it's the oxidizing agent. Get it? CuO is the oxidizing agent.
oh, CO is the so
Agent.
agent.
Because it is reduced.
And it is reactive.
And then H2 is oxidized. This one's oxidized, so it's the reducing agent. So D. Get it now?
Yes.
Okay. I will save this and put in your